Hello, squad. Today I want to teach you the difference between rational and irrational numbers. So you know the drill. Open your math notebook, make this the title on the next page. After that's all set, close it up and just concentrate for a little bit. Let's see, fractions and decimals. Going to be very, very important today. Probably back in 6th grade, you learned how to change fractions into decimals and decimals into fractions. So we take, say, a fraction like a fourth. To change that into a decimal, you treat this as division. 1/4 is the same as 1 divided by 4, which is that over here, 1 divided by 4. And that's how you change it. If you want to change the decimal back into a fraction, you have to know how to say it. So when I look at this, that's the 10ths place, that's the 100ths place. So we would pronounce that 25 hundredths. And if I can say that, 25 hundredths, I can write the same fraction, change a decimal into a fraction. If we did some dividing and some reducing, we would be able to turn that back into that. So that's fractions and decimals. And also, our title talked about irrational and irrational numbers. You may have heard those words in other life than math. They have nothing to do with their normal meaning in math. In normal meaning, rational kind of means logical, and irrational kind of means not logical, illogical. What they mean in math has nothing to do with those meanings. So if you've heard a person or an idea called rational or irrational, it just kind of means logical and not logical. That's not where we're going with it today. So if you know those words in the rest of your life, different in math. So here we go. So first thing to know, there's 3 types of decimals. Some numbers, be them decimals you see or fractions, are called terminating decimals. And those would be like 2/5. If I did 2/5, change it just ends. It's that. Terminating means end. So it's just a decimal that just ends. A little, if I do 3/4, 3/4, same thing. It's going to be a decimal that ends, that terminates. And it's totally fine if it already has a whole number with it. So if you did, something like this, that's going to be a decimal that ends. Those are called terminating decimals. We even count numbers like 4 that don't have any fraction or a decimal, because if you write it with a decimal, you can just do that and it ends. It's called a terminating or ending decimal. That's one type of decimal number. Not all decimal numbers you may be familiar with end like that. Some of them are repeating decimals, and they are decimals that repeat over and over and over and over and over again. One you run into a lot is 1/3. If you change 1/3 into a decimal, it is 3 repeating, 3 over and over and over and over again. We write that like this. With this symbol over it means repeating decimal. 3's on and on and on. And the 3's never end. My calculator just ran out of spots, but it would keep going on and on and on and on forever. 2/9 is another one of those. If I change 2/9 to a decimal, it repeats. 2, 2, 2, 2, 2, 2, 2, 2, 2. And they don't have to all repeat to be repeating. If I do 1/6, you'll notice there's a number before it repeats. 1/6 is that. So it's a 1, then a bunch of 6s. This makes it look like it ends with this 7, but it doesn't. It just rounded the last 6 up to a 7, because calculators round decimals if they run out of space. But there's really 1 and then 6 forever and ever. So you would write that like this and a line only over the 6. If you write a line over the whole thing, that means it alternates 1/6, 1/6, 1/6, 1/6. And that can happen too. It's not always one decimal repeating. Sometimes it's a whole bunch. So those are called repeating decimals. What's important to notice about those, you notice I started with a fraction for all of those, even this one if you want to think of it as 0/10 or something. And here these were all fractions. What's important today, it is possible to write any terminating and any repeating decimal as a fraction. It is possible to do. If I see this decimal, it's possible to write it as that fraction. If If I see this decimal, it's possible to write it as that fraction. With a repeating decimal, you don't know how to do it, but you can. You just need to know that it's possible. Terminating decimals, you do know how. This is 4/10, which you can reduce to 2/5. So where I want to go is it is possible to write terminating and repeating decimals as fractions. Even if you don't know what the fraction is, it's possible to do it. And there's one other kind of decimal where that is not possible. So some things are non-repeating and non-terminating. So for instance, the first one you learned about was pi, back when we studied geometry earlier this year. Pi is a decimal number, 1415926, I think. And it goes on and on and on and on. It doesn't terminate, non-terminating, it doesn't end, and it doesn't repeat. So different than a repeating decimal, which they also go on and on and on. This one never repeats a pattern. And you could look out 10 million digits of this decimal, and there is never a repeating pattern anywhere. Some others we've run into recently are what I've been calling messy square roots. The square roots that you don't know the square root of, like say 2. If you take the square root of 2, also a non-repeating, non-terminating decimal. 141413562373095, on and on and on and on. And you'll notice it also doesn't repeat. Nothing in there repeats over and over again. Totally random new decimals forever and ever. 4213. It doesn't end, non-terminating. It doesn't repeat, non-repeating. All the messy square roots do that. Pi does that, and all the messy square roots. You take any other messy square root you don't know, 94. It's going to be 1, 2. 695359714832658. Again, never repeats, never ends. So all the messy square roots, same thing. So these decimals that never end and they never repeat, it is not possible to write those as a fraction. There is no fraction for this decimal. You can't write pi as a fraction. It can't be done. Same with these square roots. So terminating and repeating decimals, you can write them as a fraction. It is possible. These other ones that we've run into lately with square roots, it is not possible to write these as fractions. So these have names. Terminating and repeating decimals, anything you can write as a fraction is called a rational number. And anything it is not possible to write as a fraction is called an irrational number. Okay, so let's get to some examples of those. So here, rational numbers, remember these are you can write it as a fraction. Doesn't mean you know how or even what the fraction is, but it either terminates or it repeats. So this is a rational number, right? It's a terminating decimal. I could write that as 3 5/10. I know how to do that one. Okay. This is a rational number. I know how to write that as a fraction too. That's 8 162 thousandths. It is possible to write it as a fraction. This is a rational number. Shortcut. It says, you can write it as a fraction. If it's already a fraction, well, then you already wrote it as a fraction. So that and that, those are both obviously rational numbers because they're already a fraction. You don't even have to think about it. This is a rational number. I can write that as the fraction 9/1 if I want to. I don't usually, but I can. It's possible. This is a rational number. You'll notice that is a decimal that repeats 1616161616. I could rewrite that as that. So that's a rational number. I don't know what fraction that is, but I know that since it is a decimal that repeats, it must be possible to write as a fraction. Same with this one. 3's that never end, on and on and on and on. 3's, it repeats. I could just write 3 repeating. That's the same as 1/3. I happen to know that one. I don't have an easy way to teach you how to write a decimal into a fraction. There is a way to do it, but it's pretty complicated. But again, the key is not that you know the fraction, just that you know that you could. because it repeats, it is some fraction. Okay? Square root of 81 is a rational number. That is 9 or negative 9. Totally fine. The ones that aren't rational numbers, they're called irrational numbers. Remember, these are decimals that never end or never terminate, and they never repeat. The square root of 3 is one of those numbers. Never-ending decimal, no repeating pattern. That is an irrational number. Square root of 50, that's not a perfect square, so I know when I do it, it's going to be messy. Never ends, never repeats. So far, the only irrational numbers we have learned about are pi and any square root that's going to be messy. That's it. So that's another way to do it. I don't have a way to show you a whole lot of never-ending decimals other than those two ways. Okay. Go ahead and open your notebook and let's do a couple quick examples of these here. Go ahead and pause now. Write this down. Let's do a few examples. Unpause and I'll put a few examples. Leave some space here for me to show you a few. Okay, so terminating decimals. Terminate means end. They're decimals that just end, like 6.2 or 5.774. Those are terminating decimals. It is possible to write those as fractions, and they are rational numbers. Repeating decimals, they may just be one decimal that repeats. They may be 3 decimals that repeat. 3, 4, 5, 3, 4, 5, 3, 4, 5, 3, 4, 5, 3, 4, 5, 3, 4, 5, 3, 4, 5. Or it could be like we saw this one, where the first digit doesn't repeat, but the second digit repeats. That still counts. So those are repeating decimals. It is possible to write these as fractions. You don't know how to do the repeating decimals, but I just want you to kind of know if it's a decimal that repeats, you could do it. Somebody can do it. Okay? Non-repeating, non-terminating decimals are irrational numbers. That would be numbers like pi, and any, you can even write any messy square root. For example, the square root of 30. You know, if I work that out, 5 and never ending, blah, 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 blah. It doesn't repeat, doesn't end. So that's just a few. So these are called irrational numbers. Here's where your kind of divider goes. If it repeats or it terminates, it's a rational number. You could write as a fraction. If it does neither, it's an irrational number. Few just to categorize, bottom of your page. Oh, no, I want to do the vocab first. Sorry, we'll do a couple examples in a minute. I do want to kind of talk about the vocabulary terms as well. Here, this is kind of in the way, sorry. Sorry, so I'll try to hustle up. So just the word, right? In math, the word rational means can be written as a fraction. And irrational means it can't. Don't confuse that with those words in everyday life. Normally, everywhere else, rational means logical, and irrational means not logical. Totally different thing. That's just so you get used to that word. Not a huge deal to know that, but I just don't want it to be confusing. All right, so real fast, irrational numbers are pi and the messy square roots, since I'm out of time. Any messy square root are your only irrational numbers. Rational numbers are repeating decimals and non-repeating decimals. I'm sorry, repeating decimals and terminating decimals. I do a bad job when I'm rushed. And these both can be changed to fractions. As I wrote at the bottom here, you don't know how to turn a repeating decimal into a fraction, but you can, even if you don't know how. That's what matters. I'm not going to ask you to do it. I just want you to know that it can. Y'all, I'm out of time and I probably rushed. So if I confuse you, please, please, please go back, give this a second look. I want you to come to class mega super confident tomorrow. And once you do, can't wait to see you then.